What is going on, everybody? It's been a while since I put a video together, so I figured I would make something. Got a new computer, and just didn't have everything set up anymore. So here is a map of the eclipse totality, the eclipse that we just had back on the 8th. You see this red dotted line here is the center of the totality. Anything within that first red part there, if you were inside that zone, you would see the total eclipse. Anything outside of that zone would not see a total eclipse. You'd see a partial eclipse. And I got to thinking about the math that we're actually seeing in this eclipse event. So I went and I took a couple of points on this map, Boise and Miami, and I went into Stellarium and I got the view that was seen from those two positions at the same time that the view in Hot Springs, Arkansas was in totality. There was a line I drew in Google Maps, or in Google Earth, from Boise to Miami, and Hot Springs was on that line, so I just figured that would be a good place to start with. And as you can see, Boise, Idaho, down here at the time that the eclipse was in totality in Hot Springs, the moon was a little bit below the sun and to the east of the sun. This is the east of the sun because you're looking in the sky, it's backwards. So west on the ground, east in the sky. The moon in Miami was to the northwest of the sun at the same time. And so what we're looking at here is parallax. Just like if you were to hold your finger up in front of your face and close one eye and then switch your eyes, open the other one and close the one you had open, you'll see that your finger appears to be moving left and right in relation to the background behind it. That's what you're seeing here, just on a much larger scale. If one of your eyes was in Boise and one of your eyes was in Miami and you blinked them back and forth and the moon was your finger, you'd see the moon moving back and forth left and right in relation to the sun, which was behind it. And I posted this asking, what could you infer from this? And Yaffer did come to the correct conclusion that what you can infer from this is that the moon is closer than the sun. And I believe this shows that the moon is a lot closer than the sun. But let's take a look at this in Stellarium here. Here's the date of the eclipse at the time, 1:50 p.m. Central Time. And in Hot Springs, we're looking at the total eclipse. And like I said, I just changed the location at that time to Miami. Not Miamisburg. What is this? Miami. There we go. Oh, I need to change my settings down here. Let's go. Where's the moon? Where are you at, moon? Alright, we'll zoom out. There we go. So here's the moon and the sun. We'll just center on the sun here. And then we switch our location to Boise. That's the wrong place. I don't know how to use Stellarium. Here we go. Boise. And we see the moon is on the other side of the sun, basically. Moon was over here. Now it's over here. So let's take a look at what we've got going on here. I'm going to turn off the atmospheric effects so we can see better. So the moon, if we were to take and measure the angle, we know the moon was over here. Let's go ahead and just go back to Miami real quick. Miami, North America. Okay, so it moves almost half a degree, which is the size of the moon. The moon is now over here in Boise, here in Miami. So let's just pick a spot on the moon, say this dark little spot here towards the center. We'll use that as a reference. And we're going to drag that over here to about where we think it was. And then we'll switch back to Boise. was close, but not close enough. We're trying to get to right here. So we'll start at the same place. We'll drag it to right about there. Is that right place? Yeah, right about there. So we're looking at about 36 minutes, which is how far the moon is different between the view in Miami and Boise. The moon is showing about 36 degrees of parallax in relation to the sun. Now the sun, in relation to the other stars in the sky, doesn't move. You can take this star over here, for example. If we switch the view between Boise and Miami, that star will be in the same place. Where did Miami go? There we go. Nothing really changed except the moon. So the sun does not shift in relation to the background. The moon is shifting in relation to the background because of the parallax. So like I said, that shows that the sun is much further than the moon. And we take this number, 36 minutes of separation there between Miami and Boise. If we were to go into our angular size calculator, we could take that size and that angle and we could get a distance. And the size in this case is going to be the distance between Boise and Miami, which from here to here is 2,363 miles, which is of course a curved distance. We would be better off with a straight line distance, but I'm not going to try to calculate that. So we'll just go with our 2,363 miles. So we go back to the angular size calculator. Where did it go? Over here. The angular size calculator, 2,363, I believe is what I said. So we're going to calculate for distance. We're going to solve for distance, and we're going to do our angle in minutes. I believe we said it was 36 minutes. Let's double check that. 36 minutes, yes, that's close enough. So our angular size will be 36 minutes. The size of our base here, like I said, it's going to be the distance, which I forgot what it was again, 2,363 miles. 2,363 miles, and we'll calculate. And that gives us this funky number here, 2.2565 e plus 5. Let's just zoom in on that, make sure everybody can see it. 2.565 e plus 5. So this is scientific notation, which means we need to take this decimal place and move it over 5 spaces, which if we do so, 1, 2, 3, 4, 5, that puts us at about 225,000 miles. Is that right? 1, 2, 3, 4, 5. Yes, this would be 1, 2, 3. There you go. 225,000 miles would be the distance to the moon using those numbers to calculate it, which is not far off from the distance that the moon is from the Earth in the globe model, which is based on reality. So that's all I wanted to show you guys, that the parallax between the moon from one location on the Earth to another location on the Earth shows that the flat Earth conjecture doesn't make any sense. If the moon and the sun are the same size and on the same plane on a dome somewhere, you shouldn't see this. What we see is a moon which is much closer than anything else in the sky. The sun, the stars, the other planets do not show the parallax that the moon shows, obviously shows, when you view it from two different locations on the Earth. You could do this any time of year. You don't have to have a solar eclipse to see this. You just take a picture of the moon from two locations at the same time with stars in it that you can see in the picture, and you can measure the distance, the difference in the parallax that it's showing, and come up with a similar measurement, a similar distance to the moon. So that's all I have for you today. Thanks, guys.